Now we need to compute our denominator here, right? And so what we need for this is we need our sample size for both groups and we need our standard deviation for both groups. And as I mentioned earlier, this is sort of a plug and play situation. Be sure, absolutely sure, to follow your order of operations. That is absolutely essential for this. If you don't, it's going to mess up the whole equation. So let's start with this very long complex equation here. Let's go through every single one of these components so you know what we're talking about. Your book, just a quick note, where I have DF, that's degrees of freedom. Your book will have the actual degrees of freedom formula down there. It's just easier for me to have degrees of freedom. So it's the exact same formula, but since we know the degrees of freedom already, we can just plug that in. All right, so let's take a look at the numerator of the left side of this equation here. So we have n sub 1 s squared sub 1 plus n sub 2 s squared sub 2. So what this is saying is we need the sample size of group 1 times the standard deviation of group 1 squared plus the sample size of group 2 times the standard deviation of group 2 squared, all divided by degrees of freedom. All right, and then the right side of the equation is the sample size of group 1 plus sample size of group 2 divided by the sample size of group 1 times the sample size of group 2. So let's plug in all of these equations. So there's a lot here. I understand that. There's a lot going on here, so just kind of follow along with me. So numerator in the left side of the equation. So we have 14. We know our sample size. We know our standard deviation of group 1. So that's 0.31 plus our sample size of group 2 times our standard deviation of group 2 squared. Now I put the parentheses around this to identify that we need to square the standard deviation first before we times that with 11, right? And that's all divided by 23. On the right side we have 14 plus 11, which is our two sample sizes for each group, and then 14 times 11, which again, sample sizes for each group. And then if we move down here, what I've done here is squared the two standard deviations. That's all I've done in the next equation, and everything else is the same. So let's move on to the next piece of this. So what I've done here is I've calculated everything across. So I've done 14 times 0.096, done 11 times 0.048, and what we have here is 1.35 plus 0.53 divided by 23. Again, we need the equation, or excuse me, we need the parentheses up there because we need to add those together first before dividing by 23. Then we have 25 divided by 154. Move on to this, move on to the next piece here. What we have is the square root of 0.082 times the square root of 0.162. Then we take the square root of each of those. We find 0.286 times 0.403, right? So like I mentioned, very long equation, but it goes fairly quickly. Just again, make sure that you have your order of operations here. Again, this is why we use things like SPSS and Excel to calculate these things. Right, so now let's move on to our final step of this. Should be step 4C. We need to actually compute this test statistic. So we have our two components here, right? We have our numerator and our denominator. So our numerator is 0.31, denominator is 0.115, and we plug those in. What we get is 2.69. And so what we need to do here, this is our t observed value. We're comparing this to our t critical value, and this determines whether or not we accept the null or we reject the null, right? So we'll talk about that right now. So again, let's move back to the logic of this, right? So what is the probability of obtaining this result by chance? So we have our t critical value, right, which is 1.714 at our alpha level of 0.05. And then we have our t observed value, which is 2.69 at our alpha level, which tells us that our alpha level is less than 0.05 in this situation, right? And so what this is telling us is that we can actually reject the null hypothesis. Or to put that in another way, our stats class, the average GPA for our stats class is significantly greater than the average GPA of the sample of our methods class, right? Because this falls in the tail, right? So what we're saying is the probability of this result happening by chance is less than 5%. It's very low, and so we are sort of accepting our hypothesis here, right? Or in other words, rejecting the null hypothesis. So this helps us make our decision, right, and interpret our results. So in statistics, it's a little tricky, and we want to be thoughtful about this because it can be a little funky here, right? So there's certain elements in statistics that we want to make sure that we report, and these elements are the mean, standard deviation, and sample size for both of our groups. We also want to record our critical region. We also call this the p-value, so you'll see this in my statement here in a second, and it'll say p is less than 0.05, and this is referring to our alpha level. And we also want to report our test statistic, or our t-statistic. And so if I were doing this study and I got these results, this is exactly what I would say. I would say something to the effect of, an independent samples t-test found that on average, students in statistics have better grades than students in methods, right? And we want to report the sample size, mean, standard deviation for both groups, as well as that t-statistic. And what you can see here, and actually what I forgot in these elements, is that we also want to report the degrees of freedom. So you see that t with the parentheses 23, that's our test statistic with a degree of freedom of 23 equals 2.69, which is our test statistic. And then this p-value of less than 0.05, again, this is our critical region, right? This is telling us that our test statistic is less than our cutoff of 5% or 0.05. All right, so hopefully this made sense to you, and meet me back in real life and we will say goodbye. That is all I have for this talk. By now you should know what the difference of the different types of t-tests are, what they do, and the steps to calculating them. Thanks for watching Stats with Chaz. I'm Dr. Charlie Collins.